Hi guys, it's math time. Hey, I already did some work on our problem solving, so we're gonna chug along today. Understand the problem. Hopefully you've done yours, because you're supposed to have your whiteboard right in front of you, have done your problem solving. What was that? On page 548, and hopefully you've done all that, and you can follow along with me, and we'll see if you found a certain way to solve it that I didn't. So I wish you were there, that I could actually see your work and we could do some exchanging of ideas here, because that is what math is all about. So many different ways to solve problems. Actually, that is what life is about. There's so many different ways to solve problems. So anyway, this is what we're doing though. Understand the problem. So John has a coin, one coin, and he's going to flip it 3 times. So what our problem is we're trying to find how many different combinations could he come up with. And I think in your book it said, well, if he flipped it 3 times and it turned up heads 3 times, it would be heads, heads, heads. That would be the one of the combinations. Well, how many other different combinations are there if you flip 3 coins? So when we come down to plan, what did you put for your plan? I thought maybe one of the things you might have put was an organized list. So you could have put and the way I did it was I said H equals heads, T equals tails, so that I'm not having to write out heads, tails. I can think about what I'm doing rather than spending my time writing. So you could have HHH, you could have HHT, you could have HTH. There's all these different ways. Hopefully, when you made your list, you did it in an organized way, so you'll know if you left one out. So hopefully an organized list, there will be a pattern to it. You know, in math, we like pattern. So an organized list, there's a pattern so that you know if you just did heads, tail, heads, tails, tails, tail, heads, tail, how would you know if you did them all? So if you organize and thought, okay, I'm going to do the H is going to be the first one. How many different ways, if I have H first, can I do, and then continue on? So I don't know if you thought about it or not, but a tree diagram is also really an organized list. It's a different way to do it, because when I think of organized lists, a lot of times I think, oh well, I have a table and I can do it like that. That is like an organized list, which it is. A tree diagram is also an organized list. Let me show you. I'm going to erase all of this. Hopefully you all are with me on this. You guys have been doing problem solving for so long. I'm sure you've got the understand, plan, solve, check down. So let's go to plan. We know we have a coin. Remember when we did the lunch where we had the water bottle and then the peanut butter, or I don't remember what it was, ham sandwich, something. And then he had the fruit, and we did our tree diagram. This is going to be very similar, but whereas we had water and then we branched out to 2, and then we branched out to 3, this tree diagram is going to look a little different. I don't know if you could tell what that looks like. That was a mess. If we had water, and we've got ham and PBJ, and then he had the 3 fruits, you could see what your different combinations are. Boom, 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 and then you could go this way, and then you could go that way. So we're going to do the same thing with the coin, except we're going to start with heads or tails, because there's only 2 ways that this can turn out if you flip the coin. So let's go heads, tails. Okay? That's the first flip. It's got to be either heads or tails. Now, he's going to flip it for the second time. Okay? So the second time that he flips it, if it was heads the first time, okay, so this is flip 1. Now we're going to go to flip 2. So if he got a head the first time, he could either get a heads or tails the second flip, right? And then if he has a tails, he could also get either a head or tails on the second flip for that. All right, now let's go to flip 3. So if he does heads on the first flip and he gets heads on the second flip, he could also get either heads or tails on the third flip. If he got heads and then tails, he could also get heads or tails on the third flip for that. It's going to work the same way with the tails. So now, from our tree diagram, I can write all of those combinations down over here. I've got heads, heads, heads. Heads, heads, tails. Okay, now I followed all of those top branches. Head, 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 then head, head, tail. Now I'm going to do the bottom branch. Head, tail, head, and head, tail, tail. Now let's see the combinations for if we get the tails first. Tail, heads, heads. Tail, heads, tail. Tail, tail, heads. And tail, tail, tail. How many combos is that? 1, 2, 3, 4, 5, 6, 7, 8. 8 combos. Okay? Did you get what I did? You know what? You may need to rewind and watch this 1 or 2 times, maybe 3 times, if you don't quite understand. It's a very good problem for figuring out different combinations, and that's a skill that you'll be using a lot as you get older and in your more advanced math classes, which you guys are heading into. So it's kind of just a clever way to find combos. All right, now did it check out? Yes, we used every combo that we had available. We listed all the combinations for heads and tails, and if you just kind of guess these and you didn't have these in an organized list, do you see how it would be really easy to leave one of these out? There's not a possible combination that could happen that we didn't account for. It's a very logical, orderly way to do it. That sounds familiar. That's what Mrs. Thomason and Mrs. Pullman, that's the way we like to see you do things. Very organized, very logical way, okay? So, that's that for problem solving. Let's go right into math. The math lesson is really, it's kind of it's not even kind of, it is. It's built on what we learned about yesterday. We learned about multiplying by 100, 10, and 1,000. Well, you can take that same principle, like let's say 32 times 100, right? We have these 2 zeros on the end, so we can just put those down in our answer, and just 32 times 1, and 3,200 becomes our answer. We can do that with other numbers that end in 0 because it works the same way. It doesn't necessarily have to be 100. It can be 200, 300, 400. It can be 80, 90, 70. If you know your multiplication tables, like I know you all do, then it's really very easy. For instance, if I gave you the number, you have your whiteboards there, why don't you erase them? What if I gave you the number to multiply 70 times 80? So if you put that on your board, you probably came up with something like this. Is that what you got? Hopefully you got 5,600. All right, but let's think about what I asked you to do. 70 times 80. All right, they both end in 0. But do you know what 7 times 8 is? Yes, 56. Then you just know, add on 2 zeros. Zeros are 5,600. You can do it right up here, which makes it very convenient if you're out at the store, if you're trying to figure out something in the backyard that you need to know. Let's see if I have 80 feet of fence, 70 feet. You can just do it in your head, and you don't have to go get your marker board or a piece of paper to write it down. So it's one of those, what we're trying to build on today is a skill with mathematics that is called mental math. We have done we've practiced a little with our mental math. We're going to be doing that more now that you know your multiplication tables. And also I want to get into with you on your mental math is how to add up numbers that don't add up very easily. How can you add those in your head? Like say 17 plus 22. A lot of people, okay, if you're doing 17 plus 22, 2 plus 7, carry my 1, yes, you can do it that way, but it takes a long time and you get confused. There are different things you can do with mental math to make it a little easier. And it's what you've got to do is try to make the numbers easier to do in your brain. And so there's some tricks that we'll be working on too with that. But today, that was really our math lesson, is just trying to know, if you know your multiplication table, 7 times 8, you can do that in your head, 56, add on how many zeros on the end. There are 2 zeros on the end, so I would need to add on 2 zeros to my answer. You won't really need to have to write this down, okay? Let me give you one more to practice. Let's say it's 40 times 50. Well, you know 4 times 5 is 20. You have 2 zeros, 20 and 2 zeros, 2,000. You didn't know you were such a genius mathematician, did you? I've told you that you are. Okay, your math lesson for today, lesson 86 odd. 86 odd. And pay attention on problem number 1. It's wanting to know, what is it wanting to know? The time. If she wants to arrive at 8:10 and it takes her 20 minutes to walk there, what time would she have to leave? You know you're going to need to work backwards, right? Okay. So number 3, it's a couple of steps. It gives you the price of several different things, and then it gives you the tax. So you're going to have to keep adding, and then it wants to know if you gave a certain amount of money, what would your something in the air here? What would your money be? What would your change be? So there's several processes, several steps on that problem that I don't want you to just quit when you think you have one done. Keep going, because it's several steps. Number 5, you remember how far it is a quarter around the clock? If we have a clock and the minute hand is up at the 12, all right, how many degrees is it for the clock to go 1/4 way around? This should look very familiar to you. What kind of an angle is that? It is a right angle. How many degrees in a right angle? Good job saying 90 degrees. I heard you saying that. That was very good. 90 degrees, a right angle, okay? So if it goes down 90 more degrees, you have 90 and 90. That would be 180. Remember, we learned that a straight line is a 180 degree angle. But if the clock hand keeps going, which is what problem 5 wants to know, you're going to have to keep adding to get your answer, okay? How many total degrees are in a circle? 360 degrees, okay? So all of those things. Now, on number 5, it wants to know how many degrees are in this angle, but what it wants to know is also, it says, explain your thinking. That means words. You're going to use words to tell me, how did you get this answer? Okay? Explain. I want to see words. I don't want this. I want you to use your words. Okay? All right. Number 13. Be careful. It is a $30 and you're subtracting numbers from all those zeros. So you're borrowing. So pay very attention to your place value. Number 17. It's a multi-step problem. Your test, a lot of you did what was in parentheses first, but then you didn't go back and plug in what they were wanting you to do with that. So if there's several steps, don't forget. 21, Haney-Addy method, but you should be able to do problem 21 in your head. What's 60 times 30? Well, if you know what 6 times 3 is, 18, and you're going to add 2 zeros on the back, okay? All right. Number 23, be careful when you divide. Remember. And guys, I'm going over these problems so that when you're doing your homework and you're thinking, I'm stuck, you can always come back to this video, play it back, and hopefully it's one of the problems that I've worked with you. If not, I'll get to that in a minute. 23, $6.27 divided by 3. You have to divide every one of these numbers by 3. You can't skip them. 6 divided by 3 means what can I multiply 3 by to get 6? 2. Prove it. What is 2 times 3? 6. Subtract. Remember, dead monkeys smell bad. So we've divided, multiplied. Now we're going to subtract. 0. Bring down your 2. Can you get any 3s from 2? No. You have to tell me. No, I can't get any. How do you do that? You put a 0. You can't just bring down the 2 and the 7 because you can't get any 2s or any 3s out of 2. Put that 0. It's very, very important to your answer to your problem, okay? So don't forget to do that. Problem number 27 has this in it. 2 to the 3rd power. What does 2 to the 3rd power mean? Not 2 times 3. The answer is not 6. Remember, exponents. How many 2's? 3 2's. 2 times 2 times 2. Okay? And on 29, don't forget to tell me which one's perimeter, which one's area. You're off. Get out of here. Do your homework. Now, let's go over the procedure. Again, the answers to these problems are going to be posted tomorrow morning. So they will be up when you get up, and you'll need to check your own paper, get a red pen, and I put in the directions. You can use a flare because you're kind of the student and the teacher checking your own work. So if you want to use a flare at home, you go for it. But check your work. If you don't understand why you missed a problem, be sure and mark it. Keep all your homework papers in your folder, because Friday morning in class time, I'm going to have everybody, I want to see lesson 85, and everybody's going to hold it up, and I'm going to go through and check and make sure everybody has it, okay? Lesson 86. So that's the time then we're going to go through. Do you have a problem? Do you have a question about something? Do you not understand something? That's when I'm going to work the problems for you, okay? Because I want you to understand. It's critical that you understand why you are doing what you're doing, okay? All right. See you tomorrow, guys.